All right, good evening and welcome to Master Talker online class. In today's video, we'll be talking about capacitors in series and parallel. Okay, but first of all, let's talk about capacitors in parallel. Let us have this. If you want to draw for capacitors in parallel, you have this one, and this one. Right? This is the capacitor here. There's a capacitor here, and there is a capacitor here. Right? Now, how do you know that capacitors are in parallel? They are not being connected by, okay, they are not being connected by a straight line. Okay, they are connected individually. They stay on their own. That is capacitor in parallel. Another way we can have it, we can have another one like this. Okay, maybe let me draw the battery. Anyways, let me draw the battery. Okay, this is the battery. So the next one is I have something like this, and this is a battery here. Okay, I have the first capacitor here. The second capacitor here, and then the third capacitor. Okay, so please notice, in drawing your own capacitor, don't mind my own. These lines must be equal to show that it's a capacitor, but for a battery, one must be bigger than the other one. So if you notice this, there are three things for a capacitor. The first one is maybe the charge, the potential difference, and then the capacitance. So let me say that for this one, I have that the charge is Q1, the charge here is Q2, and charge here is Q3. All right, the capacitance is C1, C2, C3, and then the potential difference, that is the volt. Let me call it, for this one is V1, V2, and V3. All right, the same thing is applicable here. C1, C2, C3, Q1, Q2, Q3, then potential difference 1, potential difference 2, potential difference 3. All right. In a capacitor, okay, if a capacitor is arranged in parallel, you remember P to P, please. Remember P to P. What does P to P means? P to P means that if a capacitor is arranged in parallel, that the potential difference across them must be the same. So if you can get the the total potential difference, it means the same potential difference here and here and here are the same. Okay, so for capacitors in parallel, P to P, capacitors in parallel, the potential difference. And what is potential difference? Potential difference means V. So the potential difference V must be the same across each of them. All right. So if the potential difference is now the same, it means that what? That the charge are not the same. All right. Remember, if the potential difference are the same, it now means that what? That the charge are not the same. So now, if they are arranged in series, it now means that what? Since we have said that the potential difference are the same for parallel, it now means that what? That the charge are the same for series. All right. Then the potential difference are not the same. So let's continue with the parallel. And since we say that the potential difference for capacitors in parallel are the same, then our formula will be derived by the charge. Listen to it now. If the potential difference is the same, you are deriving with the charge. Okay, but if the charge are the same, you are deriving with the potential difference. So we are deriving with the charge. It means that what? Q total is equal to what? Q1 plus Q2 plus what? Q3. All right. And what is your Q? Don't forget what our Q is. That campus vibes are always charged. So campus vibes are always charged. That is an acronym I use in remembering that. And campus vibes is my group. All right. Please, you can subscribe. We are called Campus Vibes. We are students. Okay. Vibes here. All right. So please follow us on all social media platforms: YouTube, Twitter, Instagram, and the rest of them. All right. Campus Vibe. Please. This is students. that have talent. All right, this is where they show their talent. Okay, I'm a founder of it, so please, you can follow us and subscribe to that channel. Okay, so this campus vibes is what helped me to remember this formula. That, and those children are very energetic, they are charged. So campus vibes are always charged. So Q is equal to CV. So don't forget that that is an acronym. So Q means what? Charge. C means what? Capacitance. And V means what? The potential difference. So now, so if you now replace this here, you will see that I have CT, VT. So anywhere I see Q, I'll replace it with CV. So is equal to what? C1 V1 plus C2 V2 plus C3 V3. All right. Now, and I told you that the potential difference across capacitors in parallel are the same. So what does it mean? It means that V1 must be equal to V2 and it must be equal to V3. So let me represent them with VT. Okay. So what does it mean now? Let us put it. So CT VT is equal to what? C1 VT plus C2 VT plus C3 VT. All right. So if you see that they have VT in common, I can factorize. So I have CT VT is equal to what? C1 plus C2 plus C3, all in bracket of what? VT. So if VT can cancel VT, we are seeing that what? For capacitors in parallel, to get their total capacitance or to get their equivalent capacitance simply means to just add them up. C1 plus C2 plus C3. Okay, that is that for capacitor in parallel. So don't forget that capacitors in parallel, that the potential difference across them, P to P. Always remember P to P, right? That the potential difference across capacitors in parallel are the same. Okay, capacitors in parallel has the same potential difference. And what is potential difference? Your V. So that is that. So let's talk about capacitors in series. Capacitors in series. Capacitors in series. So now, for capacitors in series, what do you do? It's very, very simple. So let us draw it. Now, capacitors in series are gotten by, you will notice that they are all arranged with just a straight line. Okay? If you are moving, you must jam the other one. All right? So that is that. I have my battery here. So that is capacitors in series. So for capacitors in series, don't forget the three things. I have my C1, C2, C3, Q1, Q2, Q3, and then V1, V2, and V3. All right. Now, don't forget P to P. P to P means capacitors in parallel, that the potential difference are the same. So if the potential difference are the same for capacitors in parallel, then the charge are the same for capacitors in series. And I told you that the one that are not the same is what we are using for our derivation. So since the potential difference here is not the same, we use charge here because charge is not the same. That's why we use charge in deriving it. But here, the potential difference are not the same. So we're going to use potential difference to derive it. So we'll tell them that what? V total is equal to what? V1 plus V2 plus what? V3. So don't forget a formula that said campus vibes are always charged. C is equal to campus vibes. So they are always charged. So if I make my V subject of formula, it shows that V is equal to what? Charge over what? Over capacitance. So let us now put it everywhere. So I have what? Charge Q total all over C total is equal to what? Q1 over C1 plus Q2 over C2 plus Q3 over what? C3. Now from here, you will notice that I told you that for capacitors in series, that the charge are the same. So Q1 must be equal to Q2 and it must be equal to Q3. So let me represent all of them since they are equal by QT. So I'm having that what? Q1 QT over CT is equal to what? QT over C1 plus QT over C2 plus QT over what? C3. All right. So if you factorize that now, because they have it in common, if you factorize it, you are going to have that what? Qt over Ct is equal to what? 1 over C1 plus 1 over C2 plus 1 over C3. And they all have my Qt in common. So now, if this can take care of this, I will now have the what? 1 over Ct is equal to 1 over C1 plus 1 over C2 plus 1 over C3 plus 1 over C3. So this is how to calculate the equivalent capacitance of what? Capacitors that are arranged in series. All right. So the last thing we're going to do is now energy stored in a capacitor. Then we now solve calculations. All right. Energy stored in a capacitor. So the energy stored in a capacitor. All right. Now for energy that are stored in a capacitor, energy stored in a capacitor is given by 1 over 2 CV squared. Please, okay, the energy is what? Campus vibe squared, CV squared. Very, very simple formula. This is the only one I need you to remember. Don't forget, just forget the rest. Once you can remember this one, you can get the rest. What do I mean by that? Just remember that campus vibes are always charged. Okay, so C is equal to what? From this one I can get any one I want. Okay, I have that Q is equal to CV. So if I'm giving charge, then I can get my C or anything from here. If you want to get your V, you will know that what? V is equal to what? Q over C. So anywhere you see V here, just put Q over C to have the what? E is equal to 1 over 2 C. Instead of writing V now, I'll write as what? Q over what? C, all squared, which is what? My E is equal to 1 over 2 C times Q squared over C squared. So one of these will cancel one of these to have that what? 1 over 2 Q squared over C. So that is another one. Okay, that is another one. So another one is from campus vibes is charged. From campus vibes again is charged. I can make my C subject. So if I make C subject of the formula, C will now be equal to what? Charge over what? V. So what do I mean by that? Permit me to finish it up here. So I'm still having the same formula. I thought that it's only this one that I need. So my E is equal to 1 over 2 CV squared. All right. So anywhere I see C now, I will now put Q over V. So I have that what? My E is equal to 1 over 2. Instead of C, I'll put it as what? Q over V, then times V squared. So this will cancel one of these to have that what? 1 over 2 QV. So that's the third one. So, but I don't need to remember all the three of them. Just the only this is the only one I need to remember. Once I can remember this one, then the rest is not a problem. I can always get my answer from the rest. So let us solve some calculations to illustrate what we have already learned. All right. So the first question here, let me clean this. So the first question said, calculate the charge. Calculate the charge stored. Calculate the charge stored in okay, and the potential difference across each capacitor given in the diagram below. Right? So what do? You have this. 1 minute. So in the diagram below, they gave us something like this. I thought that once you can connect them with just a straight line, then you will not know that they are what? They are arranged in what? In series. So, but if you cannot get them with a straight line, then they are arranged in parallel. So this one they say is 1 mum farad. This one is 2 mum farad. This one is 3 mum farad. Okay, and they have been crossed by 120 V. Okay, now don't forget your P to P before you start answering anything in capacitor, in a capacitor arrangement, whether in series or in parallel. Remember your P to P. What does P to P means? It means that capacitors in parallel have the same potential difference, so that the potential difference across them are the same. So if the potential difference across the one in parallel are the same, then the charge across the one in series are what? The same. So the first thing I need to get is the total charge. Once I can get the total charge, then to get anything here is not my problem again. So let me get the total charge. All right. So I will tell them that what? First of all, the total capacitance is now what? 1 over C total is equal to 1 over 1 plus plus 1 over 2 plus what? 1 over 3, because they are in series. So 1 over C total is equal to what? The LCM here is 6. So I have 6 plus 3 plus 2. So what do I have? 1 over C total is equal to what? This is 8, 11. That is 11 over 6. All right. So if you now turn it around, you'll be having that what? That your C total, turn this one and then you turn this one. So my C total will now be what? 6 over 11 mum farad. So which is what? My C total is what? Is equal to what? 6 over 11 times 10 raised power minus 6 farad, because mum means times 10 raised power minus 6. All right. So I've gotten the total capacitance. So now it will now help me, and they gave me that the total charge, because all of them are being connected by this potential difference. So the total potential difference they gave me is 120 volts. All right. So now I know that campus vibes are always charged. Q is equal to CV. So, and it is total here, total here, total here. So my QT is now what? 6 over 11 times 10 raised power minus 6, then times my V is 120. So if you do that, you are going to get, what do we have? If you get the total charge, right? So the total charge, where is the charge? Let's say we should calculate the charge. Calculate the charge stored. Okay. So for the charge stored, I don't have my calculator. Okay. They got 65.5 times 10 raised power minus 6 coulomb. Okay. Which is anything raised power minus 6 can be mum. So which is what? 65.5 mum coulomb. Okay. So this is the total charge. And don't forget that this total charge is the same charge that is crossing here. Okay. So the charge stored in each of them is the same. So the charge stored in the C1 is the same, in the C2 is the same, in the C3 is the same. So now we can now calculate the permit me to solve it here. We can now calculate the what? The potential difference across each of them. Okay. But I know that campus vibes are always charged. Q is equal to CV. So my V is equal to what? Q over what? C. All right. So for V1, the first one, V1 is equal to what? Q over what? C1, which is what? My Q is 65.5 mule farad divided by my C1 is 1. So my V1 is now the same 65.5 what? Volts. All right. So for V2 is what? Q over C2. Why am I using this same Q? Is because it's the same potential, the same charge that is across them. So it will now be what? 65.5 divided by what? By 2. Why didn't I use this one? I don't use this one because it's the same thing as mu farad, and the one we have are equally in mu farad. So the mu can cancel the mu. I get it. So you now have what? This divided by this, you have don't have my calculator. So I have 32.75 volts. All right. For the last one, V3 will now be what? Q over C3, which is what? 65.5 divided by the third one is 3. So I now have what? If you divide it, you have 21.83 volts. As simple as that. All right. So that is that. So the next question. They said if the capacitor in okay, sorry. They say okay, if the capacitor, sorry, they say calculate. I don't want to use, they say calculate the potential difference, okay, potential drop across each capacitor and the charge stored in each capacitors 1 mu farad, 2 mu farad, and 3 mu farad arranged in series. Right? Solution. So arranged in parallel, in parallel. Okay, solution. So what do? If they are arranged in parallel, you can decide to draw it if you want. If you want to draw it for them, you will have something like this. So this one is the first one, this one is the second one, and this one is the third one. So they are all arranged in parallel. And they are being connected by, arranged in parallel and connected to, connected to a battery of 120 volts. Okay, they are all connected to a battery of 120 volts. So I have 120 volts here. Okay, so now, so I have the first one, 1 mu farad, 2 mu farad, 3 mu farad. Okay, so what do we do now? This is a very simple question. So the first thing you get is the total capacitance. You can get the total capacitance, then you are done. But before getting the total capacitance, you should be aware that the potential difference across each what is it called, across each capacitor in parallel are the same. So let us get the total capacitance. C total is equal to what? C1 plus C2 plus C3, which is equal to what? 1 plus 2 plus 3. So which is what? 6 mu farad, which is 6. I want to draw a line here, which is what? 6 times 10 raised power minus 6 farad. Okay? I've gotten the total capacitance across that. Then they say we should calculate the potential difference across them, right? The charge and the charge as well. So we tell them that the potential difference across them is 120. They are the same. Don't forget. So the potential difference across this. So the potential difference or potential drop, okay, across each of the capacitor equals 120 volts. So it's the same potential difference that is across them. So what we need to calculate now is the charge. But I know that campus vibes are always charged. Q is equal to CV. So what do we have? Q is equal to C1. For Q1 is C1V, which is what? What is my C1? My C1 is what? 1 times the volts there is what? 120, so which is what? 120 mum coulomb. Why did I use mum coulomb? Because I'm using 1 mum farad. Okay, so for q2 is equal to what? C2v, which is what? 2 times what? 120, which is what? 240 mum coulomb. So the last one, q3. For q3, I have what? C3v, which is what? 3 times 120, which is 360 mum coulomb. So that is that for that. Very, very simple. All right. So the total charge across them will now be what? If you want to get the total charge across them, Q total across them is what? Q1 plus Q2 plus Q3, which is what? We have 120 plus 240 plus 360. So what do you have? You have a 720 mule farad. Okay, that is that. Very, very simple. So we move to the next one. Okay, so we have this. So that here is 2 mule farad, 1 mule farad, 3 mule farad, and then I have 300 volt battery. Okay, so then I said 2 capacitors, two capacitors, 1 mule farad and 2 mule farad are connected in parallel, and this parallel arrangement is connected in series with a 3 mule farad capacitor, all right, and to a 300 volt accumulator. Then I say calculate the maximum charge stored. Calculate the maximum charge stored in each capacitor. Okay, and the potential difference across each. Okay, now if you look at this is very, very simple. Without telling us that 1 and 2 and 1, or 1 and 2 are connected in parallel, then connected to 3 in series, it's very, very obvious that these two are not being connected by a straight line. There is no straight line you can use to get it. Look at that. If you decide to move this way, you are not going to a particular battery, so they are not connected in series, they are connected in parallel. Then but the two of them are being connected to this series. So what do? First of all, to get the total capacitance in parallel, then it will now make it to be in series. You will now work with this one in series. So you tell them for C in parallel should be what? 2 plus 1, which is what? 3 mum farad. Then the C total will now be what? 1 over 3 plus 1 over 3. This 1 over 3 is for this one, then plus 1 over 3 for the other one. Sorry, 1 over C total. All right, so 1 over C total will now be what? LCM is 3, so 1 plus 1. So I have 1 over C total. 1 over C total is equal to what? 2 over 3. So my C total will now be, so turn this one as you have turned this one. That is 3 over 2 mu farad. Okay. Now don't forget that the potential difference across capacitors in parallel are the same. That is P to P. Don't forget your P to P. So since you have gotten this, we can now get they say we should calculate the potential difference across each of them. All right. It is very, very obvious that the potential difference across the one in parallel are the same. So the potential difference across these two are the same. So if I call it V1, let's say that V1, let me call this one V1, V2, and then V3. All right. Since here is C1, C2, C3. Then I have my Q1, okay, Q2, and then Q3. All right. For V1, V1 is simply 300 volts. We are not calculating it because they are in parallel. Another one again, V2 is equal to 300 volts. Yes, they are the same. So, but for V3, V3 is what? Don't forget, campus vibes are always charged. So tell them that what? Q is equal to what? CV. So to get my V3 will now be what? Q over what? C3. All right. So have I gotten my total charge? Oh, I've not gotten my total charge. So let me get my total charge. For my total charge, I'll tell them that what? Campus vibes are always charged. Q is equal to CV. So my Q total will now be what? The C total, which is what? 3 over 4. Sorry, 3 over 2 times my V is 300. 300, then mu column. Okay? Which is what? 900. In fact, this divided by this is 150. So 150 times 4 times 3 is 450 mu coulomb. Okay. So this will not help me. And don't forget that what? That the okay, this will not help me to have that what? 450 divided by 4 450 divided by what? 3. And 450 divided by 3 will give you 150. So I have that here is 150 volt. All right. So that is the one across so that is the one across V3. So now let us now calculate. We have calculated their volt all through. Let's calculate their charges. Don't forget that the charge across capacitors in series are the same. So automatically my Q3 is equal to what? That 450, the total one, 450 mu coulomb. So but my Q1 will now be what? Make U subject here. You have that Q is equal to C1V, which is what? What is my C1? That is 1 times 300, which is equal to what? 300 mu coulomb. Okay, that is for my Q1. My Q2 is equal to what? C2V, which is what? 2 times 300, which is what? 600 mu coulomb. So that is that for that. Very, very simple to calculate. Right? How did I get my charge, my total charge? 450 coulomb is my total charge. Okay. So what about? Oh, sorry. This is not correct. There is a mistake somewhere. And what is the mistake? Sorry. Let us calculate again. Sorry, there's a mistake. So this is the total capacitance, all right? So let us get the total charge. There is no way you can be solving them the same. You cannot be solving them the same. For the parallel side, you solve parallel different, then solve the distinct difference. So the total charge across them now, the total charge across them, the total charge across them is what? C total, V total, sorry. So which is what? My C total will now be, that is 3/2 times my V total is 300, which will give me I think 450 mu coulomb. Okay, that is the total charge across them. Now we want to get the potential difference, that is across this particular two, because the potential difference across here, okay, let me show you the potential difference for V3. Okay, sorry, for V1 and V2, the same potential difference here is one across here. So for V1 is equal to 300. Yes, V1 is equal to 300. Yes, V1 is equal to 300. Okay, 300 volts. V2 is equal to the same 300 volts, because the same potential difference that crosses them. Then, but for V3 is different. So how do I get my V3? My V3, don't forget that campus vibes are always charged, CV. So my V will now be what? Q over C. What is my Q? My Q is 450. 450 divided by my C is 3. So my V3 is equal to what? 150 mu coulomb. Okay, that is my V3. So I've gotten my V1, V2, and V3. So, but for Q1, Q2, and Q3 now, for Q3 is the same charge that moves across them. The same charge is what is moving across them. So, and what did I get as my charge? The total charge I got is 450. So for Q3 is 450 mu coulomb. Now, but for V1 and V2, for V1 and V2, for Q1 and Q2, the charge, the potential difference that is across here is what entered here, and not this total one. Are you getting me? So this one I calculated now, the V3 is the same one that is moving here, because when they are in series, their distance is not the same. So to calculate my Q, I said that campus vibes is always charged. So my Q1 will now be C1 V3. I'm using the same V3. So which is what? My C1 there is 1 times 150, which is what? 150 mu coulomb. Then my Q2, okay, is what? C1 V2. Okay, so but because they are in parallel and the potential difference across them are the same, so the potential difference here is what entered here. So I'm not talking about the one all, okay, for all. Okay, so what do I have now? That is my C2. My C2 will now be 2 times 150. That is what? 300 mu coulomb. So that is that. Okay, so we'll move to the next question. So you have to be very careful to know that the potential difference across the one in parallel are the same, but for the one in series are not the same. Right? So I have a capacitor C1 is equal to 4.5 mu farad, 4.5 mu farad or microfarad. Well, I call it mu, but they call it microfarad here. Okay, so it's the same. So microfarad is, but micro is 10 raised power 6 anyways. So it's a mistake. It should be mu farad. So, but they call it microfarad is charged. It's charged to a potential difference of 120 volts. Then I say if the charger or battery is removed and the charged capacitor is connected to another uncharged capacitor of C2, which is 6 mFarad. Now say calculate, number 1, calculate the final potential difference. Calculate the final potential difference across the circuit. B, calculate also the energy stored in I in the original capacitor before connecting to another. II, energy stored in the two capacitor in parallel. All right. So we want to calculate the charge. So let us get our parameters. Our parameters said that what?